Assalamualaikum and hi guys. Today I would like to deliver chapter number 7 entitled of relationship between distribution and abundance. And here is our chapter outline for this topic. And before we start, we continue. The outcome-based education, after finish this chapter number 7, you should be able to understand about relationship between distribution and abundance. And if you look at this chapter outline, there are 4 subchapters here, which are number 1, definition and distribution of and abundance, definition and distribution and abundance. Number 2, spatial scale of species geographic range. Number 3, relationship between distribution and abundance, divided into 2 chapter 3 here about hollow curve and common rare. And last one, Hansky's 1982 rule. Okay, mention about sample model, ecological specialization model, and local population model. Okay, this is about distribution. Distribution is actually about spatial arrangement of population members, and abundance means relative representative of a species in particular ecosystem. So this is about distribution and abundance. Okay, who live where? What limit or constraints about geographic distributions? So what is the relationship between distribution and abundance? Of course, this is considering the question, do species that have large geographic ranges are more or less abundant than species that have small geographic ranges? Okay, if you look at large geographic ranges, more abundance, or small geographic ranges, less abundant, is it? So if you look at here, this is a spatial scale of geographic ranges from the smaller scale into the largest scale. Okay, down there is a smaller scale, and up there is a larger scale. Okay, how do we define a species geographic range? We may refer to figure 8.1. Okay, before that, if you look at here, for the large scale one, the upper one, the arrow, if you look at the arrow here from your left hand side, okay, the largest scale is actually about worldwide entire world. Okay, accordingly, and the smallest one about clump or a small or close group of trees or animal species. So this is about spatial scale of geographic ranges. Okay, this is figure 8.1. okay, about what? Analysis of geographic distribution, okay, of the mass tetrapece. Okay, I think you will carry it by yourself. It's very easy to understand, just about the largest and the smallest one. Okay, this one also the same thing, the scale, okay, from the largest to the smallest. Figure 9.2 shows that as the spatial scale increases, the correlation getting weaker. Okay, also variation in geographic range size. Okay, most species in a group have small geographic ranges, but few have large geographic ranges. Okay, if you look at figure 8.2 and figure 9.3 about birds and vascular plants, it shows the hollow curve. Okay, so this is, we can summarize the distribution for small geographic ranges. There are most species, okay, abundance of most species, whereby for large geographic range there are abundance, actually a few species only can be living there, living there. Okay, so this is just figure 9.1 about what I've told before, about a frequency histogram of geographic range size of 635 species of North American fishes, F, and 1370 species North American birds, okay, or B, A and B. Okay, sorry, the fishes is F, and B, if you look at the graph there, F is representative of fishes, and B representative of birds. Okay, so ranges are grouped into 1 million square kilometer classes. There are many more species with small geographic ranges. Okay, so this is just differences, okay, between the large and the small one. Again, figure 8.2, this is geographic range size for birds, North American birds, and for the plant. Okay, if you look at that, frequency distribution of geographic range size for A, 1370 per species of North American birds, and B, birds up there. Okay, down there is a plant, species of British vascular plant. Most species have small geographic ranges. Okay, so this is data from Edison 1985 and his friend. Okay, this is about Rappaport rules by Stephens 1989. Within the mammals, geographic range size decreases from polar to equator. Ranges in the smaller in tropics. Okay, so figure 8.3, if you look at that, is for trees, fishes, sunbirds, reptiles, by Gaston et al. 1998. Okay, if you look at that, the blue color one, the arrow from your left hand side, this one, so this is the geographic range decrease, and down there is geographic range decrease. So that's why they said within the mammal, geographic range size decreases from polar to equator. Ranges is smaller in tropic. Okay, this is another figure 8.3. Geographic range for 523 species of North American mammals, measured as the percentage of the total land area of North America. So if you look at your right hand side, okay, this is about that. Up the upper one, the first graph, the blue color one. Okay, so B down there is a relationship between range size and latitude. Low latitude species have smaller ranges than high latitude species, following Rappaport's rule. Okay, why do some follow Rappaport's rule while others don't? While others don't? What are the ecological mechanisms of such a pattern? So this is the answer for that. This is about ecological mechanism of distribution pattern. Okay, what's that? Number one, climatic variability is greater at higher latitudes. Animals need to have wide or broad tolerance range, broad tolerance, broad ranges. Okay, two predictions here. Number one, for terrestrial plants and animal, tolerance for climate should increase from tropic or lower altitude to polar to higher latitude. Okay, higher latitude have greater climate availability, true for amphibians. Meanwhile, for marine shallow water fish, temperature tolerance is minimal in both tropic and polar, but wider at temperature zones, so wider temperature fluctuations. Okay, this is related to figure 8.4. So this is figure 8.4. As you can see from here, critical temperature limits for marine fish from shallow waters according to the climatic variability. Hypothesis temperature fish should have the widest temperature limits. Okay, upper critical temperature, the blue color one, are the blue. Okay, and the lower critical temperature are in red. This data from BIT 1970 fits this explanation well from the polar temperature comparison, and may fit the temperate tropical comparison as well, but more data are needed from marine fish living in the 0 to 10 degree latitude range. Okay, next is about number 2, ecological mechanism of distribution pattern. Number 2, glaciation hypothesis, which is as glaciers melted at north hemisphere, which is higher latitude, only species with high dispersal capacity were able to populate, and these species have wide geographic ranges. Okay, this hypothesis is a contributing factor but not major cause. Okay, and the last one, number 3, lack of competition in polar communities, which is species can stay longer at polar area without dispersing to other area. So no support for this mechanism as yet. Okay, it is untested. Okay, I think that's all. I will continue next slide later on after this. Thank you.